Hey, welcome back. So in our previous video, we were looking at the beauty of the Hello World program in Rust, and we stripped back how compilation worked, how linking happened, why we've got a main function, but what we didn't look at is what was actually happening underneath the hood with the println macro, and that's what we're going to do today. So in this video, we're going to strip back the beauty of that println macro, what the macro is, what it's actually doing, what it's calling, and then you're going to have that deeper understanding of how that Hello World program actually works. And it's beautiful. So to do that, we're just going to quickly scaffold ourselves up a Hello World program. So we'll just call that Hello Println. So we'll do that for a second. You can see it's created. So we'll just cd into that. And then what I'll do is I'll just do a cargo run. And you can see it comes back with Hello World. Now if I just open up Visual Studio Code, you can see that underneath the main.rs, we have that very beautiful Hello World. Now, as I said in the previous video, we really went into the depth of what was going on with the main function. Today, we're going to focus in on this println statement. Okay, so the first thing to point out is in order to do that Hello World, we're actually not calling a function. Although it looks a bit like a function, you see println there, there's this little exclamation point here, this bang. And that's the indicator that we're working with a macro. So whenever you see something that looks like a function, but it's got that little bang at the end there, you know you're dealing with a macro. So what's happening is that there's actually a lot of complicated code happening underneath the hood there, right? So what's got to happen is you've got to make a call to standard out. It's going to take the string that you've got, output it, get a result, deal with error codes, etc. But all of that complexity has been written away into this println macro. And that's what we're going to unpack a little bit today. So what's the difference between a macro and a function? And the quick version is functions hang around at runtime, whereas macros essentially get expanded out at compile time. So think of it as a bit like a find and replace. So when this gets compiled, that println statement, it will be rewritten with all the standard out function calls that happen underneath the hood there. So the compiled version of that code or the assembly code that gets written there, it's not going to know anything about println because that's going to be handled at the parsing stage. And again, if you want to look at some of the details of how parsing and linking and all that sort of works, check out my earlier video on Hello Rust where we go into this in a little bit of detail. So if that's the case, what we can do is expand this out and see actually how it looks underneath the hood. So to do that, first thing, I just want to cement what's going on with the macro first. So what we're going to do is write our own macro, and then you'll understand how that works. So what we're going to do is we're going to write a macro which is essentially going to square two numbers, and that macro is going to call square. If I wanted to, I could write that as a function. So if I did that, we could call that function square. We could pass in a 32-bit integer and return a 32-bit integer, and then all we're going to do is to square the number is do x times x. And then if I wanted to, I could just go the square of x is x, and then there we go. We'll pass in 2, square 2. Let's save that, and if I do a cargo run, you can see the square of 2 is 4. And that's because it's calling that function. But of course, that function is going to hang around after compilation within the assembly because it's going to be an allocated stat-based memory. Remember what I said before, with macros, none of that's going to exist after the compilation. So that square function would be gone, and we could actually just take the x times x, remove that, and then we could essentially just do x times x, which would become 2 times 2. And actually, if we save that and do that here, but then the parser underneath the hood has got the ability to perform some basic calculations. So it would actually just calculate that out, and it would be 4. So if I run that again, you're going to say the square of 2 is 4. That is what the macro would do. If I looked at the code underneath the hood, this is what would happen after compilation, because all of that expanding out and those calculations would be performed by the parser. So let's write the equivalent of the square function, but let's now do it as a macro. So to do that, what I need to do is mark something up as being a macro, and I would do this with this macro underscore rules, bang. So ironically, to define a macro, you need to use a macro. Now, it's a different type of macro. It's actually a macro that's happening at a compiler layer. It's not something that you can rewrite or do anything with, but it's kind of a neat function that you're writing macros with macros. So what I could do in this case, let me just expand that out. So I've got a macro is going to be called square. And then what you can see there, I'm doing a nice little, you see it's sort of parameterized there. So it accepts in a kind of parameter expression here. So I'm accepting in x, and then what I'm going to do here is do my x times x, and then that's going to do the result. So if I now call square here, so if I go square bang 2, and then we do a cargo run, you can see the square of 2 is 4. And then, of course, that allows me to put any number I want in there. So I could put a 10, and let's just put let x equals 10, and then we'll just do x like this so that we can be consistent, and we'll do a cargo run. And you see the square of 10 is 100. And I can just keep changing this number to whatever I want, and then it will be rewritten. As I said before, what's actually happening underneath the hood is the compiler is just going to rewrite this as 25. So that's kind of the goal. So there is a bit of an advantage. So if I can write something as a macro, I'm going to get a bit of a performance advantage over a function because it's going to deal with that at a compiler level. But again, macros bring a whole lot of sort of complexity. So now that we understand that, if we were to come back to this println statement here, for example, really all that's happening is we're trying to abstract away the complexity, or Rust is trying to abstract away the complexity of writing to the standard output, right? That's what's happening. And it wants to give the user an easier way of doing that right. So rather than importing in the modules, learn this particular command, dealing with all of the handles, etc., it doesn't need to worry about that at all. And then a user just needs to worry about typing in println, and they're going to get a fairly good result. They're going to get that sort of win straight away that they can write a hello world very simply. So macros allow you to reduce some of the complexity and make things a bit easier, which is why in things like Rust, a lot of people are using macros to do things like domain-specific languages, because they can create their own little specialized languages nice and easy, so that you don't need to learn the complexity of a full language, and it can be focused on particular tasks. So now that we understand the complexity that the println macro is actually doing, what we're going to do is write it out manually and do hello world without using any macros whatsoever. So we're going to call standard out directly, make those system calls from the standard IO system libraries, and make the call manually with no complexity of the println macro. And that will give you a proper understanding of what it's doing. So first thing we need to do is we actually need to import our standard IO libraries. So to do that, we'll just use standard IO. And then what I need to do here is essentially I want to be able to access the IO namespace. So we'll show that in a second. So that's why I'm going to import cells, because I'm going to be able to instantiate standard out. And then the other thing I need to do is I need access to the write trait. Now, I'm not going to go into what traits are in this video, but the quick version is write a trait essentially is like an interface, right, in other languages. So if you think about the implementation of a write, it's a standard function signature which is independent of the underlying implementation. So if we think about what we're going to do, we're going to be writing to a terminal in this case. We're going to be writing a string. So there's going to be, in the standard out implementation, there is going to be a method called write, which is going to write out to the terminal, and it will say hello world or whatever we pass in. Now that exact same function signature could be applied to other classes, so our other implementations. So if we wanted to write out to the file system, for example, rather than the console, the terminal, then you could have another class which is going to do the write out to the file system, but it could also implement the write trait. And then as far as we're concerned, we can have code that just does a write, and we can pass in different classes that is going to utilize that, and then it's going to work in a standardized way. That's essentially what a trait is. It's just an interface. It's a function that has a signature that then can be used in different implementations. That's what's happening underneath the hood. We're not going to worry about that in too much detail just now, though. But essentially, to make this work, we need to essentially import the right trait here, but also what I want to be able to do is simplify my code so that I can use IO as the namespace. So that's all that I'm doing here. Next thing that we're doing, again, is we're showing a complexity that is being hidden by the print macro. So the next thing that I need to do is, normally when I write a main function, I'm usually not giving it an output, but actually in this particular case, one of the things I need to do is the standard output is going to be returning a result. And therefore, I want to be able to propagate that result back up to the terminal. So when I do an exit from the main function, if there's an error or something like that, then I can exit out that result or send up that result. Same with success as well. So we are going to, in this particular case, we are just going to return the result of whatever is coming back. And we will just create our function like that. So that's all that's happened here. So now what we need to do is we need to instantiate an instance of standard out. So all I'm going to do here is let standard out equals IO. So that's why we did the import of self here, so that we could do that. And then we'll have standard out here. If I wanted to, I could put standard IO, blah, 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 and then not have to do that use statement. But we're going to make our lives a little bit easier. So now that I've got an instance of standard out, one of the things that we need to do is essentially stop anything else writing to the terminal window that we've got open. So I'm going to get an instance of the current standard out. So when I do a cargo run, I will be in a terminal at that point. I'm going to get that instance, but I want to make sure nobody else is going to be able to write to that. So what I want to be able to do is grab its handle and then lock it out. So this is what that's going to do. So I'll call let handle, and it's going to be standard out.lock. And of course, it's immutable because the value's going to potentially change. So we've got that there, and all I now need to do is do a handle dot write, and what I can do is say hello world. What's happening here is hello world. Again, we're dealing with low level system calls here, so we're actually writing out to the terminal, so we're writing out bytes. So that hello world, we're not passing through a string. What we're doing is asking the compiler to turn that into a byte array, which is happening. So we're sending a stream of bytes, and then this little question mark at the end there, all that's basically saying there is we know we're going to return a result. So when you do that handle.write, if there's any sort of errors of any sort, what I want you to be able to do is just propagate that up. So when you do the exit, you're going to return that result there. So to finish this off, what we need to then do is we need to return an OK. So therefore, if that write happens successfully, we're going to turn OK as our result to the end. So if I save that and then we do a cargo run, you're going to see we have hello world. In this particular case, it's not done the newlin like the println. So if I wanted to, I could put /n, run that, and then it's going to do hello world. What I want to do though is reduce some of that complexity. And how we're going to do that at the moment is I'm going to switch away from the explicit synchronization, i.e. doing all the locks ourselves. And what we're going to be able to do is switch that out to an implicit synchronization, just let it handle it for itself. So to do that, I'm just going to get rid of this piece here. I don't need to do all the locking, etc. So we'll just get rid of that. I'm going to take that right, and then I'm going to move that to here, and then we can just save that, and then we can run cargo run. And you can see we've now got our hello world. So one of the things that the println macro does is it doesn't let you propagate up all of the errors, etc. And that complexity is taken away. So if you remember that main function that we had fn main like this. We didn't have any results coming back. And again, the println macro is taking care of some of that complexity. So what we will do is we will just get rid of the IO result, get rid of sending that OK, and then we don't want anything to propagate up here, so we'll get rid of the question mark at the end, and then suppress the result. So we'll just do let underscore equals standard out, and then now if we run that, we're going to get the correct error. So it's going to come back with hello world, and then if any errors occur on the writing or whatever, it's just all going to get suppressed. And that's actually what's happening underneath the hood with the println macro, because remember, a main function, we're not returning anything on the outside. So again, it's suppressing some of the result codes that are happening. Now let's take a pause for a second. If we actually look at the code that we've got created here, it's still quite complicated. Although this is massively simplified, could you imagine that if you were writing Hello World in Rust, this was the first thing that you ever saw? Be too complicated, right? You would need to learn about standard IO, you need to learn about standard out and do the writes and byte strings, etc. And that's, again, one of the reasons that they created the println macros so that you could get away from this level of complication. So actually, there's even a further simplification that's happening in the standard IO library as well. I could rewrite this with a macro that is provided as part of standard IO. So let's do that. So if I do a write bang, yeah. And what I could do is tell it that I want to use standard out. I could use file system, whatever. But what we're going to do is say, go implement a new instance of standard out, pass that into the write macro. And now I can do a hello world. So also for a second, I'll put the end of line character there, /n, so that we can get hello world come in the output. So if I now do cargo run, you can see it's going to come back with hello world. So again, some of this complexity has been written away with this write bang. If I wanted to, I could call write line here, get rid of the /, and then run that again. And you see it's going to come back with hello world, but this time it's going to do the output there. Now that we understand macros and we understand how standard IO and standard out works from a system library perspective, what we can do is we can now write our own macro that does the println. So to do that, we're just going to type in macro_rules bang, exactly as we did when we were writing the square macro. So what we'll do is type in my println. So we're going to have our own version of println. Now what we need to do is accept in our own sort of argument. So I will do it exactly how we did it with the square before. So I'm just going to put in $x, and that is going to be of type expression. So to make that work, what we need to do is just import standard IO write as we did before. So to do that, we just need to write pretty much the exact same code as we did before. So we're going to suppress any result codes. That's why we're using let underscore. We're going to call the write line macro that we just used 2 seconds ago. I need to call standard IO standard out. So we're going to get an instance of the standard out, and then I'm going to just pass in through whatever parameters are called there. So now what I can do here is get rid of this write line that we've got here, and I can call my println bang, and I can pass in hello world, and I can do a cargo run. And you're going to see it comes back with hello world. But what I'm not doing is dealing with the arguments at the moment. So if I wanted to, what I could be able to do with the standard println macro is I could do something like let name equals Chris, and then, or Christopher, it's got very formal for me. And then what I could do here is pass that name in here as an argument, and then I could say hello world, pass this through. With a normal println macro, if I run that, then I would get that passing through correctly, but of course I'm getting an error because it doesn't have any rules to be able to handle this. So what I need to do is fix up my my macro so that I can accept in the arguments. So what we're going to do in that particular case is I'm going to pass in a $, arg, and then we'll have TT. So that is basically, and then we'll just put a star here. So that is basically allowing me to pass in a list of arguments in that sense. And then what I can do here is rather than passing the argument in directly, I can call the format args. Guess what? Format args, it's another macro, which is essentially going to process all of those arguments that we've got there. I'm not going to go into too much of the detail here. Now, if I save that, let's clear that out, do a cargo run. Do that again. So to make that work, what I really need to do is rather than being handling a single argument, I need to process multiple arguments coming through. So we'll just get rid of this. And what we're going to do is essentially pass in a list of arguments here. So we're just making a slight change to our macro expression. And then what we're going to do here is we're going to call another macro, which is called format args, which is going to take that list of args there, and then it's going to process that through. So now then when I run that, if I do a cargo run, it's going to come back with hello world Christopher. Underneath the hood, what is happening with the println, it is essentially a macro that kind of looks like this. So that's what's happening underneath the hood. And that allows us to have a nice, beautiful println macro like this, where we don't need to import standard IO. We don't need to learn anything about that or standard out. We don't need to do any imports from those libraries. All of that's abstracted away so that when you write that nice little hello world, you can get started super, super quickly. And I think that is utterly beautiful. However, what we're not dealing with is in order to do standard out, there is complexity in there, right? Because actually underneath the hood, it's going to have to call assembly. It's because depending on the machine that you're on is going to have different architectures. So I'm running on Apple Silicon, which is an ARM64 based architecture, which is different from an Intel machine. So there's a whole bunch of complexity there. Unix machines, Linux machines are different from Windows machines as well. So guess what? There has to be calls to system libraries. And again, that's a whole level of other complexity. And we're going to cover that in the next video.